Hi guys, Mr. Sonnenberg here. Today we're going to be talking about mass. This is for Science 7 students studying structures and forces. For study references, you can find this in topic 3 of your textbook, pages 298 and 299. Basically what we're going to talk about is what is mass by definition, how is mass created, what's the system for measuring mass, and what are some devices used to measure mass. So, mass of an object is the measure of the amount of matter that's in it. So if I was to draw two objects down here, one, and these aren't shell structures, these are just mass structures. Now if I was to draw, two objects, the amount of matter inside, well, which one would have more matter? Well, this one would have more, and this one here would have less, because there's more matter inside this, therefore it would have a greater mass. Okay, and on this side there's less, so it would have less mass. Okay, so the reason that the one has less mass and one has more mass is because in this second point right here, the mass is the number of particles the substance has. So clearly this one right here has more particles than this one right there. So therefore it's going to have a greater mass. Now years ago scientists developed this system called the metric system, and now we use it in Canada, but not all countries use it. But what they did was they took a small cylinder and they said that this is going to be our standard unit, and standard unit is what we're going to compare everything else to. So this metal cylinder, okay, and what they did was they started comparing different substances. Maybe they put different things next to it, right, and started to compare them to see in comparison how they sized up towards the cylinder. And I'm just drawing shapes, but so they had all these different objects that they would compare to this right here, which was the standard unit. Okay, so now they were comparing. So this standard unit in the metric system, they started to call this the primary standard of mass. Okay, so I'll just underline that right here for you, the primary standard of mass. And they said that the amount of material in it, in this primary standard of mass, was 1 kilogram. So I'm just going to write that here for you. So the primary standard of mass, let's underline it, and that's going to be 1 kilogram, and that would be the same as this right here. Okay, 1 kilogram. So that's our standard unit in the metric system, is kilogram. But what we're going to talk about next is how we can break those units down into smaller units and even smaller again. So if we were to measure smaller masses, we're going to measure them in grams. So with the G. So when you use a 3-point balance, which we'll talk about next as well, they have different categories where we can measure in grams, we can measure in kilograms, or we can measure in milligrams. But so we have smaller units or smaller masses, we're going to measure them in grams. Now kilo, right here, this word kilo, that refers to 1,000. Okay, and so therefore it's equal to 1,000 grams right there. Now if we get something, so this is the larger measurement, but remember the standard measurement in the metric system is 1 kilogram. But then not many things can be measured in kilograms, so for the smaller masses we want to make sure we measure them in grams. But then for things that are even smaller, okay, when we get things even smaller, then we're going to measure those in what we call milligrams. And 1,000 milligrams okay, is equal to 1 gram. So 1,000 milligrams is equal to 1 gram. Then if I take 1,000 grams, what's it equal to? Well, it's equal to 1 kilogram. Okay, so we can see basically how we have these units. So the smallest unit is going to be here. Okay, smallest unit is going to be in the milligrams, and then our largest unit is right there in the kilograms. But 1,000 grams is equal to 1 kilogram, or 1,000 milligrams is equal to 1 gram. So we can see ranked from smallest to largest that we have milligrams, grams, and then kilograms. Now, a unit for measuring mass is a balance, and you should be familiar with it. We've worked with it a little bit, but a 3-point balance is going to have three balances, 3 beam balances, and they're going to be in these areas here. Now, they're going to be in different measurements. So the one back here is going to be in 100 or in hundreds. One here is going to be by 10, and then this one is 1. So different scale. So what we can do is we can adjust all those beams when we place our object up top here. Then this arm is going to move up or down based on how we balance. So it's used to measure the amount of mass in a particular substance. So if I put a block on it like I've drawn here, then it's going to tip up and down, and then once we get it the gravity equal and the mass equal, then what's going to happen is it's going to level out, and it's going to balance, and then we can determine what the mass was based on our 3-point scale by adding all the amounts together. So like I said, it includes a triple beam, and it has 1 equal arm balance, and so that arm is going to rock up and down until it levels out, and once it levels out at the appropriate line, then what's going to happen is then we can measure the mass. So that's our tool for measuring mass, is the balance. Now, just one little point at the end here that's really important is if I was to take this rock right here, and I had it down by a tree and it's sitting on the ground, this rock right here, and its mass is 100 kilograms, and then I had it up in space, okay, with all the stars up here, and now it's up in space, okay, and it's still going to be 100 kilograms. Okay, it might float up there because of gravity, lack of gravity, but it's still 100 kilograms. So no matter where you are in the universe, the mass will stay the same. So these two will be equal, they'll stay the same. It still has the mass, because mass is actually measuring the amount of particles in a substance, right? So if I have it down by the tree in the forest, or if I have it up in space, it doesn't matter, it's still going to have the same mass. Alright, okay guys, well thanks for tuning in. That's mass, and the next screencast will discuss forces and weights. Okay, thanks for tuning in. Bye.